group and the Azure Auckland user group. This is being recorded, so if you don't want to be recorded, then please just drop off. We have a code of conduct, which is basically just be nice. And John is going to take questions at the end. So if you'd like to just put questions in the chat or just go open mic at the end of the session, John is going to leave some time for questions. So one of the things that we have been talking about is that we have these two user groups, but in a virtual world, it kind of seems weird to have them. So we're thinking about amalgamating the two user groups and maybe even bringing in the connected systems one that does all the Azure interfaces. So watch the space. That's something that might be happening in the near future. But today we've got John Downs, who's a senior engineer in the FastTrack team, and he's going to be talking to us about architecting multi-tenant solutions on Azure. So John, over to you.
Thank you very much, Rory, and hello everybody. Nice to see you all. So in this session, as Rory mentioned, we're going to be talking about architecting multi-tenant solutions on Azure. Now, all of the stuff that I'm going to be talking about today is based on guidance that we've been publishing to the Azure Architecture Center over the last year or so. So Dan Scott Ransford, who you probably know is one of the organizers of this meetup, and I and a bunch of other people have all been contributing to this guidance. And everything that we talk about today is covered in a lot more depth, actually, in this guidance. So you can get to it at this link, aka.ms/multitenancy. We're also still working on the guidance. We're still actively writing and updating the guidance. So we'd love your feedback and suggestions, and I'll provide some ways that you can provide that feedback a bit later on. Now, as I mentioned, producing this content has been a huge initiative. It's had many different contributors from different teams at Microsoft, and it's really based on our experience in working with customers like startups, ISVs, which is what we call independent software vendors, and other customers who are building multi-tenant applications and systems. So although I'm the one presenting this today, as you can see, there are a lot of people who have contributed their time and their expertise to this, and we hope you get a lot of value out of it. Another thing I want to clarify, a little disclaimer before we go on, is you might know the term multi-tenancy as it refers to Azure Active Directory. In Azure Active Directory, every customer is represented by a thing called a tenant. And Azure Active Directory can set up federations between tenants and do various cross-tenant operations. So these are all great features, but that is not what we're going to be talking about today. There's sometimes a bit of confusion about this term multi-tenancy. What we're going to be talking about is how you can build your own multi-tenant software on the Azure platform. And of course, you will be using Azure AD as part of your solution, but we're not here to talk about Azure AD tenants specifically. Instead, we're going to talk much more broadly about how multi-tenancy affects every aspect of your architecture and your design. While we're talking about disclaimers, I'm going to add another one, which is that multi-tenancy doesn't necessarily mean that every component of your architecture is going to be fully shared between all of your tenants. It just means that your solution serves multiple tenants in some form or another. We're going to unpack this a bit more later on. So as I said, our presentation today is based on this guidance that we've prepared for the Azure Architecture Center, and that guidance goes across three main sections. Firstly, we have what we call the architectural considerations for multi-tenancy. These are the key things that if you're designing a multi-tenant service, you need to think about them fairly early and often when you're planning what you're going to do. Next, we have a set of architectural approaches for multi-tenancy, and these cover the main categories of cloud services and Azure services and provide some of the key patterns and also the anti-patterns that we see customers following when they're building multi-tenant solutions. And then finally, we're also going to talk about service-specific guidance as well. Many Azure services have specific features that can be helpful when you build a multi-tenant solution. And there are also different ways that you can configure your Azure resources to meet your multi-tenancy requirements. And so we're actually building out a set of guidance for the most commonly used Azure services to point you in the direction of the features and the ways to configure things in a way that's going to make sense. We've got, I think, 8 or 9 of these pages so far, and we've got more coming soon. Now, these three sections of the documentation build on each other, and they're also targeted at slightly different audiences. The considerations guidance is really designed for the senior technical decision makers, so chief technology officers, solution architects, people who are going to think through the big picture of how a multi-tenant solution needs to work and the requirements that tenants might have. And also product managers would hopefully get a lot of value out of that content as well. The architectural approaches section is designed for technical leaders like solution architects and lead engineers and other people who decide on how specific Azure services will be used and how they'll be connected together as part of the overall solution design. And then the service-specific guidance is designed to be a very technical resource that's available to engineers and their leaders to help pinpoint specific features that they should consider and to highlight any gotchas or things to be aware of. So in today's presentation, we're going to talk through a subset of this guidance. And we're going to both look at how multi-tenant solutions can be designed and also some of those resources we've talked about to get you to the next level of detail if you need it. We're going to start by talking about some of the fundamental concepts of multi-tenancy and some of the things that you need to consider when you start to plan out a multi-tenant solution, including your tenancy isolation model, which is a really important point. Then we're going to talk about some approaches to deploy your resources and a couple of points about how to architect a multi-tenant compute tier and also a multi-tenant storage or data tier. And then we'll finish up by talking about how you can manage costs and also some options you might want to consider for pricing models if you're developing a service that you're going to be charging for. So the first concept that we really need to clarify before we do anything else is what a tenant is. A tenant is a much broader concept than just a user. So for example, a single tenant might actually have multiple users. And if you're building a SaaS solution, then usually the tenant that you're talking about is as a customer. Let's look at some examples and make this a bit more concrete. So imagine that you've got an accounting or a bookkeeping system that's sold to companies for doing things like payroll, expense management, banking, and so forth. So the customer of that accounting system is going to be an organization, and they'll store their financial records in the system. And of course, those financial records will be associated with them in some way. They'll be tagged with their ID or have some sort of relationship with that organization. That organization might have multiple users, all of whom use the accounting system, and they all work with that same set of data, that data for that organization. Although, of course, they might get different permissions to access or change the data, and those permissions will be enforced by the accounting system itself. Of course, the accounting system wants other customers too, so multiple organizations can each use the accounting system independently, and they'll all have their own financial records. They'll all only see their own data, hopefully, if all is working properly, and they'll have their own set of users. And each one will have a commercial relationship with the vendor of the accounting system. So this is what we call a business-to-business or a B2B system. And typically in a B2B system like this, tenants are those organizations who use your system. But if we consider a different example, let's think about a music streaming service. So you, as a person, might subscribe to that service. Your friends might also subscribe too. And even though you're all using the same service, all of the information about you, so your music likes, your play history, your playlists, your recommendations, they're all just for you. But now to add some complexity, you might also have a family that can subscribe together, and maybe they can share some of their things. So they can share a billing account, maybe they can share some of the data like creating a family playlist, for example. So in this example, tenants might represent individual users or they might represent families. And we call this a business to consumer or a B2C solution. So it's important to clarify who the audience for all of this is, right? And we're primarily targeting startups and independent software vendors, like I mentioned, ISVs, who choose to build and make their software available as a service, so a hosted service, either to businesses, B2C, or consumers, B2B, or consumers, B2C, or both. And most of the SaaS systems, most software as a service systems, are multi-tenanted. An ISV might also deploy their solution to their customers' own environments, so their customers' own on-premises solutions, for example, and that is a form of multi-tenancy as well. But there are also multi-tenant systems that aren't created by startups or ISVs. A bit less common, but they do happen. So, for example, if you work in an enterprise, you might have a platform team that builds out your centralized platforms like your API gateways, Kubernetes clusters, networking resources for all of the teams in your enterprise to share. And all of these are examples of multi-tenant services that kind of fit that definition of a tenant. So although it can be difficult to pin down a specific definition of what a tenant is, there are a few things that typically indicate who your tenants might be. So firstly, a tenant generally is a customer, so somebody who we have a commercial or a billing relationship with. The tenant might just have one user, as in our music streaming example, or it might be that there are many users associated with the tenant. like in our accounting system example. A tenant might be an organization, it might be a team or a division within an organization, it might be a family. And tenants represent some sort of security boundary with their own data. And probably one of the most important aspects of what a tenant is, tenants have the illusion that the system is dedicated to them. It's not usually, but it appears to them as if it is. They don't see other tenants' data coming in. So the definition of a tenant will be different for different scenarios. But when we think about a multi-tenant service, we're thinking about a solution that, however you define tenant, that will serve multiple tenants. And it could be that it's serving a very small number of tenants. So for example, if you're building a very niche accounting system for a specific industry, and you might only have a small number of customers and tenants, or the shared platform we talked about in an enterprise, or it might scale to millions of tenants, like if we're building a music streaming service or something like that. Now, as we talked about earlier, multi-tenancy doesn't necessarily mean that every aspect of our system is going to be shared between every tenant. But for it to be a multi-tenant service, that does mean that there's some level of sharing of resources. So this might just include the application binaries, right? So you could just be deploying the same application to a bunch of different places, or it could include some of the data that you're processing, or even all of your infrastructure, right? In which case it is fully shared. Now, the degree to which you choose to share your resources and the ways in which you share them are decisions that you as the platform vendor need to make. And the reason that you would want to share them is because they give you efficiencies in your cost and your management, right? It's a lot cheaper to run one set of infrastructure and share that with lots of customers than it is to deploy dedicated infrastructure for each customer. But your tenants will come along with their own requirements, and they will probably expect some degree of isolation of their data. And they'll also probably expect that the performance of the system will be consistent, regardless of what else is happening, who else is using it at the same time. So you need to think very carefully about isolation and try to find the right balance between meeting your tenants' requirements and who want more isolation, and getting the level of efficiency that you're looking for, which usually means less isolation because you want to share more resources. Now, this, of course, implies that isolation isn't just a binary decision, right? There's actually a spectrum of options available when you're architecting a multi-tenant solution. So let's imagine that we've got a hypothetical multi-tenant service that serves 3 tenants. The service itself is very simple, architecturally speaking. So let's just say it's got a web server and a database. And of course, you can extrapolate this example to many different scenarios, right? Different types of applications. Now, all the way at the very left of our isolation spectrum, you might consider deploying completely separate resources every time a new tenant is onboarded. So essentially, each tenant has their own private environment. And we call each of these deployments a stamp because you're stamping out a new instance from a template. This option gives you the highest resource cost because none of your Azure resources are shared. So if one tenant is sitting idle for most of the day and only uses the system a little bit, you still have to pay for their resources anyway, instead of being able to make them available to another tenant. But from the tenant's perspective, they get totally isolated environments. And for some kinds of workloads, especially some kinds of regulatory environments, this might be the only option that they've got available to them. It also tends to be the simplest to implement because you don't need your application to be aware of multi-tenancy. And generally, you'll use the same code between all of your tenants and the same deployment scripts and templates and so forth. So you're still getting some benefit from having your code shared between tenants, even if the infrastructure isn't. Now we can think about moving slightly towards the right of that slider by sharing out some of the stamps between some of our tenants and then using dedicated instances for others. We are calling this vertically partitioning deployments. And I should note, this is the term that we use in our documentation today. We're thinking about changing it, if we can think of a better name. If you've got suggestions, feel free to let me know. But basically, the reason that you might do this is if you have a tenant who is very sensitive to performance concerns or who has very strict data isolation requirements. So for example, in this case, tenant C might have very strict requirements. They've got their own dedicated deployments. But everybody else can share a single deployment. You can also use this kind of architecture to scale out your solution globally. So you might deploy one instance in the United States, another in Europe, another in Australia, and then when tenants are onboarded, you decide which one to put them on, and based on what's geographically closest to them. You can also use this approach to implement different price tiers with different service levels. So for example, you might have one stamp that has a much higher spec resource type than another, and you might put all of your paid tenants on that one, and then put your free or cheap tenants on another. And you can also use it to roll out new versions of your solution progressively across different stamps, instead of deploying everything to all of your tenants all at once. And this is actually how it works inside Azure. We follow this architecture quite a lot. So for example, if you deploy an app service application, you're deployed onto a stamp. There are usually multiple stamps in a region. And when we perform updates, we do that stamp by stamp. We don't do it all at once. We roll our updates across stamps progressively. Now, moving even further to the right of our isolation slider, you can also share some of the resources between all of your tenants, but then in other parts of your solution, dedicate specific resources to specific tenants. So very commonly, this is a database or another storage solution. So like, for example, in this example we've got up now, where every tenant gets their own database, but they all share the same web server. If your database tends to be the busiest component of your system, then this means that you can avoid some of the concerns around how one tenant's use of the system might affect another's. And it also makes it less likely that you'll reach some of the limits and the quotas that we'll be discussing soon. And you can also do this while maintaining shared resources, which means you're getting cost benefits, at least for those components of your system. To adopt this model, you need to have a very clear understanding of which components will be dedicated and which will be shared and why. So for example, you might make that decision based on performance. It might be based on meeting compliance requirements, cost requirements, and so forth. And finally, all the way at the right end of the spectrum, we could consider sharing everything. So every tenant accesses the same web server. All of the data for every tenant is stored in the same database. And hopefully it will be marked with the tenant ID, of course, but it'll be using the same tables or containers or whatever it is in the database. And we call this a fully multi-tenant system. It gives us some really big cost advantages because we can make effective use of the resources that we provision. It also makes it very easy for us to manage the system because everything is in one place. So we've just got one resource or one set of resources we need to configure. And it means we can take advantage of having multiple tenants too from our business perspective. So let's take our music streaming example from earlier. A multi-tenant music streaming service can do some pretty interesting things, like training recommendation engines based on every tenant's data, and then creating shared ML models that everybody gets the benefit of. And then you might even specialize those models for individual tenants, but create kind of the base model based on everybody's data. But we need to be very careful in this kind of approach to keep our tenants' data separate, especially if it's sensitive. Our application code needs to be very, very diligent about separating out tenant IDs on every database request, for example, and not to accidentally leak data between tenants. And we also need to be conscious that one tenant can't take more than their fair share of our system's resources. We'll talk about this. It's called the noisy neighbor problem. We'll talk about this a little bit later. And if we get to large numbers of tenants or lots of requests or data flowing through our system, then we also need to consider whether we'll reach any of the limits or quotas for our resources, which again, we'll talk about shortly. So as you can see, there are many different ways in which you can isolate your resources. In this discussion, we've just considered a very simple architecture with a web server and a database, but think about how this can get a lot more complex when you start to introduce other resource types. So for example, would you choose to share or isolate resources like networking, monitoring and logging, data analytics, machine learning models, messaging, identity, IoT services? So all these different categories each have their own specific considerations and concerns. And we talk about these in our guidance, and we'll also talk about some of them in more detail soon. But for now, I want to talk about another really important concept in multi-tenancy, which is limits and scaling. So let's go back to our example of having fully dedicated deployments for each tenant. Now, when we deploy these in Azure, we'll probably deploy each one into its own resource group. And most of the time, those resource groups will be deployed into a single subscription. And as we grow and onboard more tenants, we'll just keep deploying more and more resource groups with the same types of resources. So we continue to grow and grow. And eventually we get to over 900 deployments. And then when tenant number 980 comes along, suddenly we get a deployment error. This is because Azure has a number of limits that we need to be aware of. They're all documented in this article, which is at aka.ms/Azure limits. If we scroll down and look at the subscription limits section, then we can see there's a limit of 980 resource groups in a single subscription. So of course, the way to work around this is to just stop when you get to 979 resource groups, or probably, hopefully well before then. and then scale your deployment out across multiple subscriptions, each of which can contain those 980 resource groups. So you can see here how your isolation model can really affect your ability to scale and how you need to plan how you're going to scale based on the level of growth that you expect to get. But this isn't only an issue when you're deploying dedicated resources and scaling out across tenants either. Other Azure resources have limits that apply to their configurations or to their use. So for example, imagine that you're using a completely shared storage account. All of your tenants use it. And when you only have 3 tenants, that might work great. It might even work well when you have 100 or even 1,000 tenants. But at a certain point, you might try to exceed the limit of 20,000 requests per second that a storage account can support. And at that point, you'll start getting failures. Now, in many cases, you can request that some of these limits be raised, right? But there is still going to be an upper limit somewhere. Even if you get it raised, that's just buying you time. So you need to consider deploying multiple storage accounts and spreading your requests across them. But you need to only think about this in the context of your requirements. If you know that your solution is never going to get to a large number of tenants or a large number of requests per second, then don't over-engineer this, right? You don't need to worry about something that's not going to happen. But in general, in multi-tenant solutions, scaling out across multiple resources or resource groups or subscriptions is something that you really need to carefully consider. So on that theme, I'd like to now talk about some of the architectural approaches that we discussed, and I'm going to talk about resource deployment. So we just talked about scaling out and deploying tenant-specific resources. And it becomes critical to have a really good plan for how you're going to onboard new tenants into your solution. So this includes everything from establishing commercial relationships, signing contracts and understanding their requirements and so forth, to understanding any specific data residency or isolation requirements that tenants might have, even to things like how you'll handle custom domain names or TLS certificates. So you need to decide whether you're going to automate some or all of this process. Now, if you're only going to have a small number of tenants and you aren't adding them frequently, maybe you don't need to automate anything, right? Maybe then you and your team can just handle onboarding tenants manually. But if you need to onboard tenants quickly, or if you need to enable self-service onboarding, or if you're going to have thousands of tenants coming through your service, then you probably want to look at automating the whole process. And you need to plan out how you're going to deploy your Azure resources to serve those tenants. So let's consider a horizontally partitioned architecture with some of components that are shared, so the application components are shared, and a single shared SQL server, but with databases for each tenant. Now, somehow we need to deploy those tenant-specific databases. Every time a new tenant comes along, we need to deploy a database. And potentially we need to make a note somewhere of the mapping between a tenant ID, which might be assigned by our application, and the database that they're deployed to. And maybe we even need to store some connection strings or some other details that the application can use to access that database in the future. So one option is to store our tenant list in a configuration file somewhere. So for example, in our Git repository. And if we're using an infrastructure as code tool like Bicep or Terraform, this could be something like a parameter file. So when your deployment pipeline runs, it can look at the parameter file and provision the databases for each tenant defined in that file. It essentially loops over the tenant list and says, for every tenant, make sure there's a database. That works really well when you have a small number of tenants and when your team is directly involved in onboarding every new tenant. But it means that there's going to take some time before a new tenant's database is deployed because you need to wait for the next time the pipeline runs. So imagine your pipeline runs once a day or once a week. If somebody joins, they might have to wait that much time for it to run again. Or you can run it manually, of course, but then somebody has to trigger that. Another option is to treat your tenant list as data and to have your application control how new tenants are provisioned from the application itself. So you'll build something called a control plane, which might be triggered by a self-service registration form or a CRM event or the Azure Marketplace or something else entirely. And when the control plane receives a request to add a new tenant, it triggers some sort of onboarding workflow. And the first thing the workflow does is deploy the new tenant's database. Then the workflow updates the tenant list to include the new tenant's information as well as their database details. So this works really well when you need to support self-service onboarding, but you need to be very clear in your own mind and in how you manage your resources to distinguish between the two different categories of resources you've got. So first, you've got some resources that are dedicated to each tenant, and importantly, these are provisioned and managed by your application code. And secondly, you have the shared resources that aren't dedicated to a tenant, and these are going to be provisioned and managed by your deployment pipeline. They might all exist in the same resource group or intermingled between resource groups, but they need to be tracked and managed separately. And you need to be very, very clear about which resources fit into which category. Now, you can also choose to sell a SaaS solution through the Azure Marketplace, and this can reduce the friction required for your customers to subscribe to your service because their commercial relationship is with Microsoft. The Azure Marketplace interacts with your own control plane to trigger the kinds of workflows that we just discussed and manages the full lifecycle of your tenants. But you still need to build all of the onboarding and the lifecycle management workflows yourself. The benefit to your tenants is they get a consistent experience, though. And the onboarding process that you trigger might trigger automated deployments like we've just talked about, or maybe it just triggers a manual process that requires someone in your team to perform the onboarding steps. So all it's really doing is kicking things off, and then how that happens is up to you. All right, so we're going to shift gears now and talk about some specific architectural considerations when you're building a multi-tenant compute tier. So by compute, we're talking about things like web servers, application services, background services, and so forth. So anything that runs your own custom code, essentially. When you build a multi-tenant solution, there are several things to consider about how your compute services run. We're going to talk about a few of them here, but of course, take a look at our guidance for a lot more detail on topics that I don't have time to cover today. So suppose you have a fully multi-tenant architecture with everything shared, like the one we saw before. So the shared compute tier, as well as shared everything else. Now that compute tier could be Azure App Service, it could be Kubernetes, it could be container apps, it could be virtual machines, it could be any service, right? Let's zoom in on the compute tier. So typically when you build a cloud solution, you deploy your compute tier with a load balancer, which is in charge of routing traffic to some number of worker instances. So in a multi-tenant solution, as you onboard more tenants, you might need to scale your compute tier out to have more and more compute workers because the overall volume of traffic that you're getting is going to increase. So when you build a multi-tenant compute tier, it's really important to consider how you're going to do that and to use features like auto scale, event-driven scaling, and good monitoring to ensure that you're keeping up with demand and that your tenants continue to experience acceptable performance even as more tenants are onboarded. But it's also important to consider state and how this interacts with this whole process, because for many multi-tenant systems specifically, storing state on compute workers can actually become quite complex. So let's take an example request. Suppose tenant C sends a request to the web service, and the load balancer randomly selects worker 4 to receive that request. Now, as part of serving that request, worker 4 retrieves some of the data about tenant C and saves it into a local in-memory cache or onto disk. Now, when a different user from tenant C sends a request to the application, the request might actually end up in a completely different worker. And this reduces the benefit of caching the data on worker 4, right? Because worker 5 has no access to that in-memory cache. Now, this might or might not be a problem for you, depending on the volume of requests that you're receiving, depending on the type of data you're caching. All of those things will determine whether this is actually an issue or not. But if it is an issue, then one option is to try and make your load balancer smart and to try and send all of your requests from the same tenant to the same worker. But then this requires that your load balancer have some sort of mapping of tenants to workers. It also means that has the potential to create hot workers. So if every request for tenant C goes to worker 4, then suddenly you've got a whole bunch of other workers that might not be doing very much at all. And you lose some of the benefits of scaling out because of that. Another option is to use an external cache like Redis, for example, and then to share that cache among all your workers. This can be a good option, but it's not going to be quite as fast as an in-memory cache. Now, the problems we just talked about here can happen with any solution, but multi-tenancy exacerbates the problem because techniques like sticky sessions might not be enough to counteract it. Sticky sessions are usually associated with a user ID or a session cookie or something like that, rather than an entire tenant. But again, whether this is a problem for your particular solution really depends on your needs. Now, another consideration for shared components and compute is whether you might have the noisy neighbor problem. And this actually happens across lots of different components in your architecture beyond compute, but compute is where we often see it first. So imagine in the architecture that we just discussed that there are some operations that tenants perform that are very compute intensive. So maybe they involve a lot of CPU work, training ML models, for example, or maybe they use a lot of disk I/O. And let's imagine that two tenants are both using the system at the same time. Now, over time, if tenant A happens to consume a large amount, a disproportionate amount of the total system capacity, anything that tenant B could do, or that tries to do, could fail because those resources are exhausted. And it's by no fault of either tenant, really. They're both just trying to use the system as intended, but the system has this noisy neighbor problem. And this, of course, shows up as failures for tenant B, and they probably won't be very happy about it. You can even get these noisy neighbor problems if your tenants' workloads are actually all individually relatively light, but they overlap in such a way that they cause a problem. So, for example, in this case, every tenant is pretty small, but if you have a certain amount of capacity and you have lots of tenants all using the system at once, then you can still run into this problem. Now, the noisy neighbor problem is an inherent risk in multi-tenant systems. And it's something that we have to deal with at Microsoft a lot because, of course, we operate a lot of multi-tenant services in the cloud. But there are several ways that you can mitigate it. So one example is you can simply deploy enough performance headroom that it makes it unlikely that it will happen, right? If you know your kind of general level of resources required and you know the number of tenants and the profile of what they're doing, you can probably model their access patterns and then allocate sufficient resources in anticipation of any load that's coming. Another way to deal with it is to create multiple pools of resources and to ensure that the tenants that share the pool have distinct workload patterns, right? So they're not all going to be customers that are trying to use the system at 9 a.m. and 5 p.m. that they've kind of spread across different pools. And you can apply throttling or to enforce limits on each tenant as well. So you can use tools like Azure API management or various reverse proxies, or within your application code to actually apply limits on what an individual tenant can do. All right, so now we're going to talk a little bit about storage and data. And when we think about storage and data, there are actually a few different considerations, and these are the same kinds of considerations that we give for multi-tenant solutions overall, but storage and data have some specific kind of specific bent to them. So for scale, for example, we need to understand how many tenants we're going to serve, because if a solution needs to serve thousands of tenants, the way that you design a data architecture and a storage architecture is going to be very, very different than the way that you design for 5 or 10 or even 50 tenants. Likewise, you also need to have an idea of the storage requirements, and that's both per tenant and also overall. And you need to understand the characteristics of the workload. If you're building a solution for a school and that system is going to be run as part of the enrollment system for a school, for example, then maybe that's only going to be busy at specific times of the day, right, when the school opens and when it's about to close. Other solutions will be busy all day long. You need to consider whether it's a very read-heavy or a write-heavy workload, and if different tenants will have different patterns for that. All of these will help you evaluate these different models. The second category is isolation, and this is one of the big requirements that often drives design decisions. So we've talked a little bit about already data isolation, which is used to separate one tenant's data from another. So this is often because of contractual obligations or regulatory compliance or so forth. Performance isolation is essentially the noisy neighbor problem we just talked about, right? It's preventing one customer's workload from impacting the performance of another customer's solution. The third category is probably the most overlooked design consideration, but yet it has a really important impact on the cost of operating a solution, and also things like security and availability as well. So you need to think beyond just simple performance impacts and consider things like, how are you going to implement a schema change once this thing is actually up and running? Does your team have the adequate development skills to build and maintain a solution of this complexity, right? Building out a multi-tenant solution is actually quite complicated, as you probably are getting the sense. How will you monitor not just the entire system as a whole, but also individual tenants and try and anticipate problems and detect things like noisy neighbor problems? Do your tenants require high availability and disaster recovery? And if so, have they got different requirements to each other, right? If one tenant requires backups every 5 minutes, another tenant requires every hour, those are quite different requirements. And another really important area is customization. Do you allow any kind of tenant level customization, and especially in the data tier? And if so, how are you actually planning on implementing that? Are you going to allow adding custom columns to the database, or will you build an engine that allows for customization? And then we have cost. So in addition to obviously the accounting implications of cost, we can also use the cost to help us to evaluate different designs and judge the efficiencies of our designs and make that trade-off we were talking about before in isolation. So one model for data and storage is, and this is the simplest, is to store a single database per tenant. And as we talked about before, regulatory and compliance requirements can often mean that we end up going down this path. It gives us a high level of isolation and the ability to more tightly control the data for a specific tenant. And it also gives us the ability to scale, right? We can keep scaling out essentially. But it's obviously capped at whatever the scale can be provided by a single database. So we might need to pull databases together to share resources. And if we've got a large number of tenants, we might need to create something like a catalog database to store the metadata about all of our tenants, so that then their application can dynamically be pointed to the correct tenant database. We can also think about a single multi-tenant database that every tenant goes through. So this provides the highest tenant density and optimizes the cost of the database, but it means that we have the lowest isolation and potentially susceptible or very susceptible to noisy neighbor issues. We also need to think about things like those per tenant customization and data management and high availability requirements. So if one of your tenants accidentally deletes all of their data, for example, how are you going to restore that? You might not be able to do a database level restore like you could do if they had their own database. And also, do you need to measure the consumption of individual tenants? We'll talk about this a little bit more later as well. And then the sharded multi-tenant database approach kind of combines those last two approaches. So tenants are distributed across these different databases or shards, and you might have multiple tenants per shard, but you might also have some shards that are dedicated to specific tenants. So larger or busier customers might be on their own shard. So this model provides very good density with lower isolation, but with some additional complexity around how you manage it. Now, some of the data platforms like Cosmos DB actually can kind of do this for you natively with the way they do partitioning. But other database products, like, for example, Azure SQL, require that you implement some of this yourself or use frameworks that help you to do it. So these are all different options that you need to consider. And as you can see, the storage and data is kind of a microcosm of the problems you've got with multi-tenant architecture overall. Now I'd like to turn to another important aspect of managing a multi-tenant solution on Azure, which is tracking and allocating and managing your costs. So Azure provides some really great features to track and allocate costs. So things like resource tags, for example. So in this example, every resource can be tagged with a deployment stamp ID, and then any resources that are dedicated to specific tenants can be tagged with that tenant ID. That works really well when you have these kinds of resources that are dedicated to tenants, because Azure can then give you a breakdown natively of all of the costs for those resources that are dedicated to each tenant. But it's more challenging when you have shared components. How do you apportion the total cost across those tenants? So another way to track and allocate costs for multi-tenant solutions is to instrument your software. So for example, to measure the number of API requests that each tenant makes, and maybe using an access token or something like that to identify the tenant, and then build a billing metering system to track that and apportion costs accordingly. Now, there's a few different ways that you can build billing metering systems. So one approach that can work for a high volume application is to use a system like event hubs. So that can track every incoming request as an event. And then you might use something like Stream Analytics to aggregate all those events and then write the total number of requests out to a database. But it's really important that you use a system that's designed for this kind of data, though, both in terms of the data volume, the data velocity, and also the importance of the data. So for example, a lot of customers use Application Insights, which is a great service in Azure, but it is not a good choice for handling billing data or usage data, because it's designed, among other things, to perform data sampling, which means that the individual records that come through Application Insights aren't always accurate or complete. It's designed to give you a kind of a picture of what's going on, but not to capture and store every single piece of telemetry that comes in. So that leads to another consideration that you need to think about too, which is the level of precision that you need to track your costs at. Now, if you're tracking costs because you want to bill tenants directly for their Azure consumption, you probably need very accurate costs, and very accurate way to apportion those costs. But if you're running a shared multi-tenant system and your tenants are all paying, the same monthly charge, for example, you probably only need to have a rough idea of your cost per tenant. And maybe what you're really interested in is whether specific tenants are using the system a lot more than others or a lot less than others. And of course, you need to think carefully about how you allocate those costs to those for those shared components, because even something like an API request count might not give you a true picture of how much it costs to actually run a specific tenant. If API requests are usually not all created equal. They've got kind of different weights associated with them. So you need to think about whether that's something you need to really consider and differentiate. But as we keep coming back to, it's a good idea not to over-engineer this. Most of the time, for most scenarios, an approximate cost breakdown is sufficient. And it's only if you're going to be billing customers directly for their usage that you need to get more precise than that. So that leads to the final area that I'm going to talk about today, which is the types of pricing models that you can consider. Now, pricing models are very complex, and a full discussion of pricing models is well outside the scope of what we're talking about here. But I will say that pricing models and the business kind of model behind it actually matters a lot for your architecture. As usual, what I'll do is today I'll just provide a brief overview of these topics, but have a look at our guidance for a lot more detail on this, because it is a really complex and interesting area. So we've already talked about one pricing model, which is to simply bill your tenants for the cost of the resources that are used to serve their requests. So in something like an enterprise scenario, where you're not operating a multi-tenant system to make a profit, you just want to recover your costs, this can be a really good option. But in a SaaS solution where you're you're trying to run a commercial business, it's common to look at other pricing models. And of course, your business model will have a lot to do with this. So a simple pricing model is to charge each tenant a flat rate. So regardless of how much the tenant uses the system, they will pay the same price. But if your instrumentation shows you that some tenants are using the system far more than others, then this might be a pretty unfair distribution of costs. And especially if you start getting noisy neighbor problems, then customers are probably going to get unhappy about paying the same price as somebody else who's using it in a way that's going to impact them. So you could instead look at moving to a billing model where you bill for the amount of use by each tenant. And as a tenant uses more of the system, their bill goes up. But this makes it more difficult for you as the vendor to predict your revenue and your costs. It also has a kind of a perverse incentive for your customers because it means they're actually motivated to use your system less, which probably isn't what you want. Now, another option is to use a freemium model, which is very common in SaaS solutions. So this is where you get some set of capabilities for free, and then the tenant needs to pay to unlock more capabilities. So for example, your free tier might not provide a service level agreement. There might be limits on how many API calls a free customer can make each month. You might only allow, say, 10 users within a tenant and so forth. But then if the tenant pays you money and moves to this paid plan, then they'll get support, they'll get an SLA, they'll be able to use the API as much as they like, and maybe they can have more users as well. And similarly, you might not provide a free tier, but you might instead provide multiple tiers at different price points and with different feature sets. So when you use either the freemium or the tiered pricing models, you need to think really carefully about how you're going to enforce this architecturally. So for example, how will you enforce API limits on your lower level customers? Azure API management might be a good option to do that, but of course you need to think about what you're using in your solution. How would you enable or disable features depending on the tier that the customer is on? Well, does that mean that you have to deploy different stamps and put a customer onto a particular stamp for a particular set of capabilities? What happens if the customer upgrades or downgrades? How do you move their data around? And if you need to give your gold tier customers some sort of performance or isolation guarantees, then maybe you need to deploy dedicated infrastructure just for them and use some of those different types of isolation models that we spoke about before. Again, thinking about this from a practicality perspective, you need to understand that whatever pricing model you choose, remember that you are responsible for implementing it. And so if your pricing model or your business model relies on knowing exactly how many requests a tenant is sending, then make sure you understand how you're metering that and tallying it up. And do you need to audit it? Do you need to provide that data to third-party auditors? How will they audit it? If your pricing model is based instead on applying limits to some of your customers, then how are you actually going to do that? Are you going to use things like API throttling and quotas? Are you going to be able to do that in some other way? What happens if you have that noisy neighbor problem we talked about before, where you've got lots of individual tenants using the system a little bit, but in such a way that the aggregate usage gets too high? And if you use a tiered pricing model, then you need to think about how you'll enable and disable features for each tenant. And again, what happens if you need to do things like move tenants between stamps or so forth. So this is a really good illustration of how your architecture is very tightly linked to your commercial decisions and your requirements. And you can't design an architecture without understanding your business model in a lot of detail. So that brings us to a few key points that I want to leave with you to take away when you start architecting a multi-tenant solution on Azure. So first, it's important to have a very clear understanding of your tenant's requirements, and don't make unfounded assumptions. So for example, do your tenants expect to have an uptime SLA? That might be in your contract, it might not be. Do they have data isolation or data residency requirements? Do they need you to meet specific compliance standards for your whole solution? I've certainly seen for myself that a lot of customers have a funny habit of not telling you these things until it's too late, and salespeople often don't ask. So it's important to be very clear upfront and make sure that everybody understands what the requirements actually are. Secondly, you need to consider your own business model and requirements. And it matters a lot, for example, whether your company treats your platform as a cost center, like in an enterprise, or a profit center, like in a SaaS solution. You also need to think about your own growth plans and make sure that you don't over-engineer for unrealistic levels of scale and growth, but also you don't want to under-engineer and get caught short if you actually do become really successful or grow higher than you expected. And you don't want to lose customers because of noisy neighbor issues that happen because your scale has been increasing as well. Third, there are many different multi-tenancy patterns and models that you can follow. And there's no one size fits all approach, and there's no easy decision tree that I can give you to point you to the right one for your solution. The way to select the right one for you is to have your requirements front of mind and to think through all of these considerations and then think about what makes sense for your solution. But remember, multi-tenancy doesn't necessarily mean that everything has to be shared across every tenant. And finally, we're here to help. So we've put together this guidance covering everything we've talked about today, as well as a lot more. Please take a look. Please provide your feedback on anything you think that we should add or change, or anything that you're not sure about. And of course, if you're a Microsoft customer and you want to use my team to help with these kinds of reviews, I'm in the FastTrack for Azure team. You can go to, I think it's fasttrack.azure.com, or azure.com/fasttrack, I should know that. And you can nominate and see if you're eligible to get some assistance from our team as well. So with that, thank you very much. There's some links here for both the content in the Architecture Center and also the feedback form. And I would love to take any questions. Thank you for your time.
Thanks, John. There was some awesome stuff there. Certainly a lot to think about. Some people won't be able to put the questions in the chat. So if you do want to ask John a question, if you look at the top under reactions, you can raise your hand there. So if you please just raise your hand, and then we'll ask you individually to come off mute.
All right, shall I drive this bit, Rory?
Yeah.
Awesome. Okay, Alvin.
Great. Hi. Can you tell me a bit about this FastTrack for Azure program that you have?
Yeah, sure. So I'm an engineer in the FastTrack for Azure team. So is Will Valida, if you know him as well. That's one of the organizers of this. So we are the customer-facing arm of the Azure engineering organization at Microsoft. So we basically work with customers to help them onboard to Azure, to do architecture reviews, to help unblock technical issues, all those kinds of things. So we work a lot with customers building SaaS solutions and thinking about these kinds of issues. We've certainly worked with a lot of customers who've done it well and done it badly, and we can hopefully point you in the right direction if we see one way or the other. So we do have some criteria that you need to meet to be able to join our program. Will, I'm hoping if you are there, maybe you could find the correct link rather than me making it up and drop it in the chat, and you can have a look at that, Alvin, to find out more about our program.
I will do so now.
Thank you very much.
All right, thanks.
Cool. Greg.
Hey, John. Amazing presentation. Learned a lot. Thank you. This is a new world for me, but one piece I was interested to hear a little bit more on was the identity side of things, considerations and questions you need to be asking when you do design that B2B or B2C platforms and identities.
Yes. Okay, cool. For this one, I'm wondering if Dan, if I can pass this one over to you, because this is right in your wheelhouse.
Yeah, thanks, John. I was wondering if someone was going to ask that. Yeah, that's actually a page we've been working on. So it came to us sort of later in the day, but it is a big challenge for everyone. And do you adopt an identity as a service platform? What should that look like? Do do each of your users potentially access multiple tenants or a single tenant? There's a lot more considerations than we first thought. So we're working on that page, and we've been working on it for a little while. So there's a team of about 4 or 5 people working through that at the moment. So we'll publish. We aim to publish that soon, hopefully in the next few weeks, and then we'll share that. But it'll go into the link that John's put there on the multi-tenant, the AKMS multi-tenancy. It will be available as considerations in there. That's a super good question.
Yeah, just in time for cross-tenant collaboration to come out and change the game again, eh?
Yeah, I know. It's a moving target, and one of the things we do find is the requirements across multiple SaaS providers are very, very different. Some SaaS solution, you're only ever going to have a federated identity solution, right? An enterprise is going to bring their own identity, and that's the way it's going to work. But others, you might require social identity providers, or you might provide, a hybrid solution. So there's a lot of different requirements that we need to surface up and make sure you've got all the questions you need to ask.
And one of the things that I think, like one of the conversations I often have with customers about identity and multi-tenancy is, customers will often come along assuming that the right way to do it is to have their identity provider inject a tenant ID claim in a token. Now that can work really well, but in many solutions, you actually want to decouple those things, because you want, for example, one identity to be able to access data from multiple tenants. And if you've got that baked into your token, that might not actually be the way you want to do it. And so then you need to look at more API-based authorization rules and so forth. So this is all going to be covered in the guidance that Dan's working on. It's a very complex set of areas. And again, we don't have single answers to point you to. It's more, there's a whole bunch of questions that you need to ask and requirements you need to gather.
Okay, thank you.
No worries. Alexander.
You kind of preempted my question there, because I was looking for guidance on how to handle large scale authorization rules around claims. If we have somebody coming with their own identity, but that comes with row level access of claims or whatnot, how to best handle that when that's going to be different for every tenant that you have. Is the recommendation more I guess the flow that I'm kind of expecting is some kind of flow chart to tell us to either do individual based authorization servers, or to do something more centralized through the B2B provider that Azure has.
There's no one size fits all approach, and we specifically don't go into flowcharts for this, because I personally hate them. I think they do a really bad job of actually getting to the nuance of what you need to understand. So I tend to throw lots of questions and then leave it to you to figure out what to do. Another big factor that can make a difference for this is how many tenants you need to federate with. Or if you were doing a B2B solution and all of your tenants are in Azure AD, and you're using an Azure AD B2B or B2C solution, then the number of tenants you federate with can actually make a big difference in terms of what's feasible and how architecturally. So again, we don't have an answer there, but in many cases I find it's better to try and keep the identity system relatively simple and move all the complexity into the application tier. So just all the authorization rules and so forth in the application tier, rather than trying to over-engineer the federation and so forth. But it all depends.
If I can ask my question on that just a little bit more, and sorry, Moses, to bump down a little bit. Would the recommendation more be around in the application tier to have several requests to an authorization server that says, do you have access to these things, or to do like an all at once? Because we've run into an issue where some of our things have too many claims in the headers, and we're running into header limits.
Yep.
And
Yep.
that's what I'm after there.
Yeah, and there is an OIDC protocol standard thing for dealing with claim overage and stuff as well. But yeah, that's again, it's really hard to get into this into any level of detail that's going to be useful in this kind of forum. But I as a general rule of thumb for many solutions that I've reviewed, the way that I've ended up recommending the customer go with it is keep the identity system purely dictating who the user is, right? And give some sort of claim to saying this user has this identity, right? And that's it. What they can do is then, for example, the result of an authorization filter in the API or something like that. And that can then be a component that you write in code, which can then go and do whatever business logic you need it to do, and figure out, is this tenant allowed to do this thing with this permission on this resource at this time? All those kinds of things can be factored in there. But yeah, we'd probably need to have a much longer discussion to really unpack your requirements there. Sorry, Alexander.
Oh, no worries. Thank you.
No worries. Moses.
Yes, hi John.
Hey.
Great presentation. Thank you for that. What if some of my tenants already have an infrastructures or workload on different cloud providers, which will obviously accumulate some egress costs. So, like, who pays that cost? Is it me, the tenant? And can a tenant actually suggest that maybe they want their data to be part of the infrastructure? Like I want my data to be, in AWS, for example, or GCP.
Yeah, I mean, we've certainly come across those kinds of situations where tenants say, I want you to run my multi-tenant service, but I want to host the infrastructure because I need to for some reason, or I don't trust the cloud, or I don't trust Azure. That's conceptually, there's no real difference architecturally in terms of what we do. Like, you'd still, in that case, you'd probably have the equivalent of like a deployment stamp. It's just that stamp would be hosted on-prem or wherever the tenant needs it to be. But of course, you'd need to think through all the implications of that, right? How are you going to get access to it for management and updates and so forth? If tenants own their own infrastructure, then suddenly your job as a platform provider gets a lot harder. Is that kind of what you're thinking about there?
Yes. Yep. Exactly. Yeah.
Yeah. So I don't think there's an established pattern for this. I've seen customers doing it, but nobody is. I don't think there's a single way to do it, and I've certainly never seen anybody do it well. I think it's always various degrees of awkwardness, but yeah, it certainly can be done.
Yeah. Is there like a YouTube channel that we can watch the recording on?
For this session, so there is for the user group. Yep. Shahid's nodding his head.
Yeah.
So, Dan, do you want to?
Yeah, we will. There will be a recording of this session. We will upload this to the Azure user group YouTube channel that Shahid and Rory look after, and that'll be made available a day or hopefully not too long after this. And we'll also post that in the meetup. There's also a recording of a similar session, which is the reactor session, John, as well, which I think
Yes,
we've got that somewhere. I think that's multi-tenant.
It's basically identical to this with a little bit of extra content actually, because we had another engineer talking about AKS specifically. So that's aka.ms/multitenancy/live for that one. But I'd say really the call to action, I guess, from my point of view, is look at the architecture center, because all we've talked about today is just skimming the surface. There is a lot more there, both in terms of the topics we've discussed and also a whole bunch of other topics we didn't get to.
Awesome. Thank you.
No worries.
And it's probably also worth, I mean, if you are starting to think about building a multi-tenant solution, you're a startup or whatever, there's also something called the Founders Hub, which is just sort of been released, which is I think it's aka.ms/Founders Hub. That is, if you don't have access to the FastTrack engineering team, that's another place you can go to get access to, to support and guidance on how you can build this stuff. So it is worth just checking that out if you're starting
And as it happens, some of us in the FastTrack team, including me, have actually put their hands up to be mentors for that program as well. So even if you're not officially enrolled in FastTrack, if you want to talk to me about your solution, then that's an avenue you could look at.
Yeah, so that's aka MS/Founders Hub. You can find that, or it's startups.microsoft.com, I think, is the other URL.
Cool.
We got through all the questions. Apologize. Yeah, the chat wasn't working for most people, so we're putting the links in the chat, but most of you aren't seeing them. So if you do have if you go, hey, what was that link? Reach out to the team on Meetup, and we can just make sure those links are shared there.
Awesome.
Awesome. Any more questions? No. Okay. Well, thank you, everyone. We had 75 people, I think, at one point, which is, I think, the highest number we've had for a long, long time, which is absolutely fantastic. And I think we're all pretty chuffed about that. So yeah, we'll see what we can organize for next month. And John, thank you very, very much for your time and for an excellent presentation.
You're welcome. I just see Ahmed has just put his hand up as well.
Yeah, hi guys. Hey, how are you?
Hey.
Ahmed here. Great presentation, by the way. And it's really, really good. And like I don't know who said it. It's a lot to get in.
Yes.
I'm just it's just more of a suggestion. Like if for next sessions, we would be able to, like, someone put 2 or 3 topics, and we would like vote on it. That would also help. And maybe if we get more information about the Founders Hub or the startup, because what does that mean when you join? Because I've seen it before, and it's just saying, like, bring up an idea and we'll take it from there. But if we could just see a little bit behind the scene of what does that mean, and because Founders Hub is sounds like a really big idea, like you need to come up with some sort of like an MVP or something like that. And yeah, that's about it. Yeah, thank you guys.
Yeah, awesome. We can certainly from a founder's perspective, I'm sure we can get someone to come in and talk to that. Shahid and Rory, that would be, if you've got a spot in the group, we could certainly get someone to come and talk about that, because that is a big support program for people who are going, like, I want to build something. I've got a genius idea. I'm going to rule the world. I'm going to build this amazing new service, and this is a network of support and resources available to founders who are coming up with the next great thing to just support them and get them going. And resources like John, who can come in and provide that technical guidance that you need when you're getting started, help you avoid making those mistakes that we see, and make sure you're successful. So yeah, that's a good call out. Thanks Ahmed. We'll see if we can get someone in.
Cool. I think that awkward silence probably says that's a good time to call it. So thank you so much, everyone, and we'll see you at the next one.
Thanks, everybody.
Hey, guys. Awesome.
Thank you guys.
Bye.
Thanks, guys.
Yeah.
Thank you, guys. Thank you.
Thanks everyone.
Thank you.